Now come for this. Ball is projected with a speed u. Let elastic collision, let it occur. And there's a pipe where the balls, they're permitted to move inside the pipe. The next sequence. Just try to analyze. Meanwhile, I'll adjust the diagrams. So first what happened? The ball B is at rest. Tube is fixed here. It's a fixed tube. Only thing is we are making the balls to move in one specific direction. So it will come and collide here, no? Just before collision, this will have speed u. They collide here elastically. So will they exchange velocities? No, masses are not equal, no? M into m. So what do you expect after collision? This will have speed and this will have speed v1, this will have speed v2. Can we calculate that v1, v2? Yes, by applying conservation of momentum and quotient of restitution formula. Again, will they collide? Again, will they collide? Yes, again, what happens? One more collision occurs. Like that, I can keep on discuss the problem. Again, where do they collide? Somewhere, some position. Okay, that we have to calculate. This pipe is fixed here. Pipe will not move. Okay, let's calculate V1 and V2 first. How to get that V1 and V2? If you can you are able to understand question, it'll be very easier. So the same collisions in different way they'll try to ask in exams. You have to be very careful about the different types of numerical. How to calculate that? So what is the initial question? The block B is the ball B is at rest and the ball A is projected with a speed u. They'll move, they'll collide. That one, like that. After, like, what is the time taken for the second collision? This is at t equal to 0. Collision will occur at time t1. This was the time t1. Again, what happened? One more collision will occur. After what time? Again, for second collision will occur. There's a question. So first we'll calculate v1, v2. So this should be mu should be equal to minus mv1 plus 2mv2. So u minus v1 plus 2v2. Quotient of restitution formula. Applying quotient of restitution formula. Look at the second and third diagram. Yeah. Now E is equal to, I'll take the V2 minus of minus V1 plus U minus 0. E equal to 1. So therefore this will be U equal to V2 plus V1. Adding up these two equations, 1 and 2, I'll get the velocity. So 1 plus 2. How much I'll get it? 2U is equal to 3V2. So V2 equal to 2U by 3. How much V1 will be then? U by 3. So after collision, this one. So definitely, who will have more speed? This will have more speed. So at what point again they'll collide? And I want that time also. They must collide somewhere, no? Because they're moving opposite to each other. Can we calculate the position and also the time taken? Let R be the radius, will take it. Radius of the pipe. How to decide where do again they'll collide? Go back to circular motion concept. Go back to circular. Somewhere let them collide. Let them collide at somewhere at position. I don't know. So somewhere here they're about to collide. They're about to collide. The first collision. They're the second collision. I want this time t2. So let them collide at an angle theta. Tell me what is the angular displacement, how much of distance it will move? Pi by 2 plus theta into r, it will cover distance. And what about the other thing? How much of distance? Pi plus, or you can say like a 3 pi by 2 minus theta into r, that the distance moved by it. So we want this particular time again where it will collide here. After collision again, they'll exchange, again you have to work out the collision concept and you have to proceed here. Okay, let me proceed here. Time taken by the ball A to move from this position to point B. Time taken by the ball A. So this should be equal to how much time this should be equal to? Total distance covered by it will be pi by 2 plus theta into r. Arc length divided by V1. In the same time, this will cover 3 pi by 2 minus theta into r by V2. You know V1, V2 equate, you'll get the theta. We know V1, V2 here. Solve this, you'll get the theta. From theta, what will happen? Substitute back here and you know V1, you'll get the time.